Hi, welcome to this lecture titled Thinking in Objects. But before that, let's do some experiment on the program that we have written. I'll take you to the program which we wrote while we were understanding about a class and object. And we created a class circle, and then we are using that circle class in test circle. So we did learn about constructors, we did learn about some getter methods, some setter methods. So here we have a get radius method, and we can write set radius also. I'll do that later. Let me try something in this program itself. I did this demo in the last lecture, which was on objects and class. Now let me try printing this thing. I should say system.out.println, and I will try to print these objects. Let me print my circle, and I should say that, let me write this thing, that I'll say contents of object my circle is, or rather than contents, let me write information about. That may make more sense. Information about object my circle is. System S is missing here. Let me do the same thing with the second object that I created, but I should say your circle. So probably you'll guess the kind of output that I should get. It's not a compiler error, okay, because my circle is an object that I have declared in the line number 5, and similarly your circle is an object which we are declaring and creating on line number 12. Similarly, we are creating the object at line number 5. So line number 5, my circle has been declared as well as created because we are calling the constructor. Same is the case with your circle on line number 12. So no compiler error. So let's try to compile this program. Java C test circle .java. Okay, good. And now I'll run this. Java test circle. Okay, yeah. So let's not look. We already know about these things. Okay, so let's pay attention to the last two statements which I just introduced in today's lecture. So this value that you're getting right here is a reference. Alright, similarly, the value that you're getting for your circle is a reference. So when you try to print these values, which are my circle, your circle, and my circle and your circle are the objects for objects of type circle. So since the objects, they store the reference value, so this is a reference variable. Similarly, your circle is also a reference variable which are holding the reference of these new objects that you're creating right here and right here respectively. So the output is these two references. Okay, so now what we will be learning, to write a method which will return the information about the object, because this information is useless to me as a programmer. Well, this is reference, that's correct. Reference means an address, that's fine. But I'm more interested in knowing about the content of the object. So when my circle, for my circle, I would like to know about the radius of my circle and probably the area of my circle. Similarly, for the second object, which is your circle, I would like to know the radius as well as the area of the second object. Okay, so let's try to understand how can we fix it. What we want that whenever we are trying to print these statements, then in place of the reference I should be getting the information about the object. So this is not tough, this can be done. So for that that purpose I should introduce you to a method. Okay, so let me introduce you to an interesting method which I would encourage you people to write in all the classes that you create. So this is something you can try for your homeworks also. Homework number 3, you can write toString method. So let's see what is the purpose of toString method. So toString method should be written in all your class to get the information or description, you can say information of the object. Okay, and this information is returned in the form of a string. So this prototype, or I should say the signature, is fixed. The signature of the toString method is fixed. So what it should be, you need to write toString method in the class, and that should be public, and its return type has to be string because the information that you're returning is a string. Public string, and the name of the method should be toString. Please don't change that. It doesn't accept any input, and then here is the body. And now here you can write the description. Okay, so write the statement with object description. And that should be returned. You should return that with return statement. Okay, so that's all we have about toString method. So what I'll do, let me write the toString method for the class that we have created. So right now, if I take you back to the circle class, you won't see any toString method written. So what I will do now, let me write this toString method, public string toString. Okay, now since the class that we have is circle, now I need to think about it, like what information do I want to return for a circle object. So here let me declare string st is equal to, so this description that I will be creating for my object, I'm storing that in a string variable, calling that st, and eventually I'll return st because its return type is string, so I should return something from this method. So what should I return? I should say st is equal to st plus radius plus area, I should say get area. This is the method that we have. Alright, so if you pay attention, I haven't done anything great in these 3 statements. What I am doing, I define my toString method. It has to be public and its return type is string, and in this inside this method I created a variable st of type string, initialize that to empty string, and then I'm concatenating the string radius and then the value of the radius for this object. Then I will be adding the string which is area, so that the area value is coming after a comma and area colon and then the value of the area, and all these values would be stored in this string variable st, and that's what I'm returning in my toString method. Now let's see, I created this method. I will save that here. I'll go back to my test circle class, and I'm not changing anything here. Line number 19 remains the same. Line number 20 remains the same. Let's try to run this program and see if anything has changed. I will compile and let me run. Okay, see the interesting information. So after writing this toString method, what has happened? I'm not getting the reference printed out anymore. I'm getting the information which I have written in toString method. Okay, so I get the radius as 1.0 and area is equal to 3.14 and 15, so on. Alright, similarly, for the second object which we have created, your circle, I'm getting the radius value followed by the area. Alright, so that's the advantage if you have written your toString method in such a way that the toString method is returning important information about your object. Then whenever you try to print that reference variable, then you will get the call to the toString method and you'll get the important information or useful information. So you might be wondering that we have created a method toString, then we should have called this method explicitly. We should have done something like this. You are right. We can do it this way also. So these two are equivalent, whether you explicitly call toString method with a period and toString, or you just leave that and only make a call with the reference variable. If you are not writing anything here after the reference variable, by default it will be a call to the toString method. So let's try this thing explicitly. You have the same result. Alright, so either you call that toString method explicitly like this, or you don't put these things at all, they'll have the same impact. Okay, yeah, so that was about toString method, which I would encourage you to start using. You have these two problems in your homework number 3. You have complex class and you have a rational class. For rational number class, you have complex number class. Why not write toString method in each of these two classes and try to print the object by just calling the reference variable. So after writing these toString methods, you can use these toString methods in your print method if that is required in your homework. Okay, so what I'll do now I can take you to the lecture, which is thinking about objects. And let's see. Now we have another class. We will discuss about a class which is provided to us by Java. It is present in java.util package. It's date. So how is this class being defined? Now since we have learned about UML, so this figure that you're looking at here will make a lot of sense, because what is the purpose of a UML? The UML gives you the structure of the class, like what are the data members in the class, what are the different methods in the class. Okay, so here we are looking at the class date class, but this date class is present in java.util package. So you will have to specify the full path for the date. You'll have to put java a period util period date. So that's the complete name of the class. And in this class we have some methods. So what are these methods? You have date. So you might have figured it out that the name of the class is date, and then you're telling me about a method whose name is date as well. So that means it's the constructor. First constructor is no arg constructor, because right here in the parenthesis we have nothing in there. The second constructor that you have is an arg constructor, where it is expecting some value. So it is expecting a value which will specify what date you are looking for. So this date class is very interesting. I will do a demo. After this slide I'll take you to the demo, and we will learn about this date class by working on an example. Now for the first constructor that you're looking at, which is date, it will return the current date. If you run this program, you will get the current date when you write an object. So let me do this thing. Let me take you to the demo itself. I hope that will be better. So right here I have a demo program written where you need to import this class, because you have to use this class to create your date object. So just the way you were importing scanner class, you had import java.util.scanner. Let's do the same for this date class. So you should say import java.util.date. Forget about the import for the time being on the second line, because we will discuss random class, that is in the next slide. Okay, great. So now what I should be doing, since the date class has been imported, I can do date d1 is equal to new date. It should be the capital date. So here I'm calling no arg constructor. Okay, so let me immediately print this thing out. System.out.println, and I am printing d1. Let's see what would be the result. You created the d1, which is the date object, and you're printing d1. So this result will give you some idea about the structure of the class, like what methods do we have. So I should say java c test date dot java, then java test date. Alright, good. So as I was telling you, when you use the default constructor for the date class, it will return the current date. So when I'm recording this lecture, it is 13th of April. Okay, and the time is 4:31. Okay, so it will return the current time if you're using the default constructor. And you should also notice this fact that I was able to print the date value. I did not get the reference value. Okay, so when we run, what we found was that current date is printed, which means that we have a toString method. Alright, I started with toString method, and I gave you in the demo that if you do not write toString method, then you should get the output as a reference value. But here, when I'm creating d1 object and printing d1 out, then I'm not getting any reference value. I'm getting some meaningful information. Alright, what is this meaningful information? This is the current date. So that means you have toString method already implemented in the date class. Okay, yeah, that is the fact. Alright, we do have a toString method already implemented in the date class, because of which we were able to get the meaningful information when we printed the object d1. If you want, you can do d1.toString as well. It will have the same impact. Now we have some other methods as well, other constructors as well. So I will use the second constructor later, but before that, let me tell you about this thing that we have a method which is called getTime. Let me be sure about that. You have getTime. Let's use this getTime and see what will happen by this getTime. So let me put this long time elapsed. I will explain what time elapsed means. Is equal to d1 dot get time. Now we will print it out. We should say system.out time elapsed till now. Time elapsed. Alright, let's run this program. Alright, so this is a big number. So now this time elapsed is the time in milliseconds from January 1, 1970 in GMT. So that's how this date method, date class has been created. If you say get time, then get time will return how many milliseconds have passed from January 1st, 1970. And this time is in GMT, which is a standard for time. Alright, so this was important for you to tell, because the next date object which I'll create will use the second constructor. So you'll say new date, but here you will specify the date that you want. Alright, so how do you specify the date that you want? You need to tell the time in milliseconds, milliseconds from Jan 1, 1970. Alright, so if you tell me that I want to find out the date after January 1, 1970, when so many milliseconds have passed, then it will return that date. Okay, so what I will do right now is, let me use this value that I have already got on the line number 7, which is anyway telling me how many milliseconds have passed from January 1, 1970, and let me do some mathematics on that. So what's the mathematics? Let me check whether this method is working fine by asking Java to return the date for 1 day earlier. So what does that mean? I should use 1 day, that means 24 hours. In 1 day we have 24 hours, and in 1 hour we have 60 minutes, and in those 60 minutes we have 60 seconds, and here we are in thinking of milliseconds. Alright, so I don't want to put space here. This should be fine. So what did I do for 1 day earlier, right? So I'll get April 12th. That's what I want to get, but I'm using the second constructor, which needs the time. So time elapsed, which I already found on line number 7, minus 24 hours 1 day earlier. 1 hour has 60 minutes. 60 minutes has 60. Wait a minute, I think I'm messing up. 24 hours, 60 minutes, 60 seconds. I think I don't need 360s. Alright, 24 hours, 60 minutes, 60 seconds, and I need milliseconds. So I'm multiplying that by 1000. Now let's print it out. I should have system.out.println. This should be perfect. And in place of D1, I should do D2. Let's see. I need to compile and then run. Alright, so you can see that, right? D1, for D1 I am using no arg constructor, so I got the current date, and I am running this program on April 13th. And what I did later, I found out the time that has elapsed in milliseconds from January 1, 1970 till April 13, 2020, and I found that number to be this, which I'm storing in my variable time elapsed, and I'm using that time elapsed and doing this calculation, like how many milliseconds have passed from April 13. So by doing that calculation, I was able to get the date for the previous day, which is correct. Alright, so I believe that now you have got the understanding of these three methods. One constructor, which is no arc constructor, then the other constructor, which expects you to provide the millisecond value so that it can return a date object for you. And then we did use this get time method, which will return the number of milliseconds which have passed from this fixed date for the specific object. Okay, so that was about the demo on date class. I'll take you back to the date class now. Okay, so yeah, we did try this constructor, the NOAA constructor. Then we did try the other constructor. I just did that in the demo. And then the toString method we figured out, because when we are printing the date object, we are getting the date value. So they have toString method. Get time we have tried. Similarly, you can use set time also. I'll say that you should try that as an example. So now you should try that as an exercise. So if you look at these statements right here, so here we are using date, and for date object we are using class as java.util.date. So you have this, it is up to you. Do you want to import class or not? If you're not importing the way I did as import java.util.date, then when you create the date object, you should specify the class with this all detail, which is java.util.date. The whole thing you should provide if you are not using import statement. And similarly for constructor also, you should give this complete description, which is new java.util.date and then the parenthesis. Okay, yeah, so this is slightly different than the way I did in my demo. Then when you're printing it out, I did not use toString. If you want, you can use toString, or otherwise also, if you don't call toString but there is a toString method written, then you'll get the call to toString. Okay, good. Now let's look at another interesting class, which is a random class. So we have been working with the problems involving random numbers, but for that case we were using math.random class. Math.random method, which is there in the math class. Right here we have an interesting class called random class, which is in java.util package, and this is very helpful. Let's look at what all we have here. So you have these two constructors. The first is the default constructor. The second one is a constructor that requires you to provide a seed. I will tell you what seed is with a demo. And then once you create this random object, then you can use this random object to generate either random integers or random doubles or random float or random boolean values. So that is the flexibility that you have with this class. With the math.random class, you were able to generate only the double values from 0.0 to 1.0, where 1.0 was excluded. But with this random class, once you create the random object, then you can call next int, and the next int also we have two versions. There's this next int method that does not expect any input, whereas the other next int expects an input. So we will try like how these two things are different with the help of the demo. Similarly, if you want the random integers to be really big, then you should call the method next long. You have next double and next float for the values, fractional values where you have decimal. And next boolean you should be using whenever you want to generate some random true false sequence. Alright, so let me take you to the demo, and then we'll get back and we'll try to uh, learn about these details if I miss anything in the demo. So I'm using the same class, and I imported java.util.random. Okay, so let me erase all these things because we don't need that. Now I'll save this one, and let me use random class rand is equal to new random. Okay, good. So what I'll do now, let me generate some random integers. Int I is equal to 0, I is less than 10, I plus plus. And here I should say system dot out dot println, and I should call rand dot next int, and I should get 10 of these values. So let me run that. Java C test date java. Okay, so now you should see. Are these random? Yes, these are. And integer has negative values also, so don't get confused. This is alright, this is perfectly fine. Integer means negative as well as positive, so it's generating some random integers in the range which is maximum integer and minimum integer that Java can return. So I was looking for this information and could not find it explicitly mentioned anywhere, but I will assume that the maximum and the minimum random integer that next int will return is the maximum and minimum integer value that you can represent in Java. Okay, so these values look really big. So we have more negative integers than positive integers. That I believe is alright. Let me run that one more time. Now we have more positive integers than negative integers. Alright, great. Now this next int, if you remember, had one argument. So let me put that argument right here. So when you use next int with an argument in there, then it will return integer values in the range from 0 till this argument that you have. Okay, so let me comment it out. Random integer in the range 0 to 100, excluding 100. Alright, so if you want, I will put that in the comment. Alright, yeah. So that's it. If you want integers from 0 to 100, you should put 100 as an argument. So let me run this for you. Alright, so yes, we did. We are not getting any negative now. Alright, because you know that this is the range. Let me run that one more time. Okay. Right, and you should know the trick. If I'm saying that I need random numbers from 0 to 100, then you need to change this 100 to 101. Now let me tell you about seed. What is seed in random numbers? So well, for random number generation there has been a lot of research in mathematics, and these methods which we use that generate random numbers are called pseudo-random number generators. Pseudo-random means they need an input. So on the basis of the input, they will give you some random numbers. So the seed is the input. Seed is an input to random number generators. Alright, so you're saying that you're making a statement and you're saying that for random number generators you need to give an input which is a seed. I'll say yeah, that's correct. But now you will ask that what is the seed here for the constructor. This constructor right here, I'm not passing anything here, there's no seed here, right? So the answer to that is for default constructor for the random, the seed is current time. Alright, so whenever you are calling the no-arg constructor to generate random object, then there the seed is current time. And whenever you run it in this way, every time you will see different random numbers generated. Okay, what do I mean by that? Let me run this couple of times and tell you what will happen. This is the sequence, right? First value was 12, then 8, 51, 83, so on and so forth. When I run that second time, you will not find the same sequence of numbers. Why? Because the seed is different. When I ran this code, it was few seconds earlier. Now when I'm running it, you should get a different sequence. Why? Because the time has been different. I'm running this program, in a time gap. So for that reason, when your seed is different, which is the time is different when you're running this, so you're getting different sequence. But if I put some seed, let me put some value like 20 is my seed now. Alright, let me not play with this because you might get confused. What I'll do now, random, let me create another rand s because I'm doing that with seed. New random, let me put some value like 20. Seed is fixed. Now see what will happen. And I should use rands because this is a different object. The first object that I am creating, rand, has the seed which is current time. So when you run it multiple times, the time will change and hence you'll see different random number sequence. But in the rand object that I'm creating on the line number 6, I'm using the seed as fixed, which is 20. So if I run that multiple times, I should not see any change in the numbers that I get. So what do I mean? Let me compile. I need to compile it because I changed the program. And I will run this. Alright, so just remember that I had 53, 36 and 1. I'll run this again. 53, 36 and 1. Probably I should not say next. Sorry, println. Let me use this thing. Now you'll see that clearly. Okay. See? Why is that happening? Keep running it 100 times, 200 times, 1000 times. You'll get the same sequence of random number. Why? Because you fix that seed, and if you fix the seed, then you'll be getting the same random number sequence all the time. Why? Because your input that you're providing to the random number generator is fixed now, which is 20. Okay, so every time you'll get the same sequence of random numbers. Whereas if you don't specify that, then it is based on the time, and then time keeps on changing and you get different sequence. Good. So if you have questions, please let me know. I find this interesting, so I spend more time on that. Okay, back to the lecture slides. Here we have the random class. These are the two constructors we already checked. Next int we tried next int with no argument, and then we tried with the argument like 100. You can experiment, and similarly you can try the remaining methods also. Okay, and yeah, please do that. So let's see what we are doing here in these statements. Here random1 is a random object which we are creating with the seed which is fixed as 3. Okay, so if you fix the seed as 3 and try it out, you will get the same sequence. Okay, you'll get the same sequence. Why? Because your seed is fixed. Doesn't matter if you run that today or maybe 1 year from today, you'll get the same sequence if you are following the same statements. But if you do not put any seed here, then yeah, you will get different values all the time for the same reason as I explained. Now you might like to look at next double and next float. So double has more precision. After decimal you get some 16 digits, whereas a double float has less precision. After decimal you get to see 8 digits. So other than that, the range is same. You will be able to get the double value from 0.0 to 1 excluding 1. So it's kind of same as math.random. Good. Let's move on. Now this is a slide which is based on our discussion on static and non-static. We had discussion about static and non-static in the previous class, but let me add more detail to that discussion. And here we are looking at the same class which is circle, but now in circle we are adding these information. We are adding the number of objects as well, because number of objects was static variable and radius is non-static. Radius is your instance variable. Number of objects was declared as static, so that is the class variable. And the radius was of type double, whereas the number of objects is an integer value. And then in the bottom you have these methods called get area, get number of objects. You might wonder, like, why did we drop the constructors? Well, you can write constructors. Just to save some space we did not write, but yes, you can write those two circle constructors. You should also write the method which was get radius. Well, I forgot to tell you some very important facts, so let me take you back to some previous slides. Okay, yeah, right here, pay attention to this plus sign, because in earlier UML we did not use plus and minus sign. This plus and minus has some significance. So whenever you put a plus before the class member, that could be a data member or method, then the plus means that these are public. Okay, so these are constructors. This is constructor, this is constructor. ToString is also a public method, right? So wherever you have a public method, then before those methods you should put a plus sign, and this plus sign means it's public. Okay, so here also all these methods that we have are public, so we have a plus before that. Right here you should see this difference, that the data members, which are radius and number of objects, have been made private. So why should they be made private? We will discuss about that towards the end of the lecture. Okay, because whenever you are creating a class, then the best practice is to make the data members private, and then you should be writing methods called getters and setters, so that if needed you can access these members outside the class with the use of those getters and setters. You should not leave these data members public, because if you leave those data members as public, then they can be easily changed from outside the class, which should not happen ideally. Great. So these two data members are private. We have a negative before that. and the methods here, which is get number of objects and get area, these are public, so we are putting a plus sign before that. Now there's another important information which is given by underlining. So any member which is underlined means that it is static. Okay, so plus means it's public, minus means it is private, underline means it is static, and if it is not underlined, then that means it's an instance member. Good, great. So that was about the structure of the circle class, and right here we have two objects, circle 1 and circle 2. Circle 1 is an instance of circle class, circle 2 is the second instance of the circle class. Okay, so how did we create these? When you call new, then an instance or an object circle 1 got created, and we specified the radius was 1. Similarly, when you created second object, circle 2 got created and its radius was set to 5. Now again we will try to understand static data members better. So what will happen here, since the radius is something which is defining circle 1, so it will have a separate memory location. Similarly, the radius right here is defining or determining the radius of the second object, so we will have a dedicated memory location for the radius of the second object. So the point is that the instance variables, they get separate memory location. So the memory location which is storing the radius of the circle 1 is different. The memory location which is storing the radius of circle 2 is different, and they have their specific values. For circle 1 the radius is 1, for circle 2 the radius is 5. But for the static data members it is different. For static data members, they have the same memory location which is shared across the different objects of the class. Okay, so there's only one memory which is set assigned for the data member number of objects. Okay, and it will have the value 0 when you don't create any one of these. But when you create the first object, then that value would be updated to 1. Okay, and later on when you create the second one, then the same value gets updated to 2. Alright, so that's what we are trying to show by this figure, which says that the static data members are shared across the different objects of the same class. So that's a common memory location, whereas the instance variables will have their own memory location. They don't share the memory location, but static data members, they do share. Alright, so we also say that static data members are something which are associated with the class for the same reason, and the instance variables are those which are associated with the objects for the same reason. Okay, very interesting, often confused, but yes, we are open to any question on that. Let's move on. Now I found this very helpful, and I put that in a slide which shows the difference between instance method and static methods. So this has to do with the privilege of these methods, like instance method. So good thing about instance method is that instance method can invoke another instance method. So here when I'm saying instance, then that means non-static. Please keep that in mind. Static, we will declare it with static keyword, and whenever you don't have static keyword in the method declaration, then that means it's an instance method. Now instance method can invoke another instance method. An instance method can access the instant data field, and interestingly, instance method can invoke static method as well, and an instance method can access static data field also. So just to keep things simple, instance method has all the access possible. Access instance method, access instance data field, access static method, access static data field. Whereas static method, for static method we have some restriction. Static method cannot invoke an instance method. Static method cannot access instance data field, but static method can access a static data field, and a static method can invoke another static method. Okay, to keep the static thing simple, static methods can only access static data field and can only invoke static method. Okay, so if you look at it and try to understand these concepts from what we have discussed till now, I believe it will make a lot of sense. Good. Now let's move on to another interesting aspect of object-oriented programming, which is class abstraction and encapsulation. So this has to do with what we have done till now. So if you could think about the random class. So in the random class, we created a random object with the help of the random class and started using that random uh, object to generate different random numbers, random integers. You can generate random double and float. You can generate random boolean values. You can generate. But if I ask you how is that being implemented, you may not have any clue. Okay, so that is something which goes behind the designing of a class. What does it mean? Well, whenever you define a class, then you give some description about what class can do for you. Okay, so when you create a class, then the creator of the class gives the description to the user, like this is how you can use your class. The creator need not define or give any idea about the implementation of the class, right? We have no clue about how these next int or next boolean has been implemented in random class. What we know is how we should be using it, right? So this is called abstraction and encapsulation as well. Abstraction means just giving overview of what we can do for this class. We are just given access to those methods. We can use those methods to get our job done. We don't know what has been implemented inside. Alright, so that is abstraction and also encapsulation. This detail of implementation is encapsulated inside the class. And this is very interesting and very important feature of object-oriented programming. Alright, so let me read these slides and see if I missed anything in my explanation. So whenever a class, the class implementation is like a black box hidden from the clients. Clients means we are using it. We are the client. When we are creating a random object, then we are the clients. We are creating a random object, and after that calling different methods. So this is your black box, and then these are the implementation inside this black box that we cannot see. And here is our client program, our main method, right, which was using a random class. And how did we use? We have to stick to the signature of the method, right? So we should know that next int is to be called in certain way. When you say rand s dot next int with no argument in the parenthesis, then you get certain range of random integers. But when you put some value inside those parentheses, then you get a different set. And if you don't follow these rules, then you get a compiler error. Alright, so the point is that the client needs to follow the contract that the class provides. Okay, so that's the concept behind abstraction and encapsulation. Alright, now the most important thing, which is about how to create your class. So as I have been telling you multiple times, and I'll keep telling you, always make your data fields private. Okay, and that thing is called data field encapsulation also, which means you should make all your data fields private so that the data is protected inside your class. If you make anything private, then that means you can access that member, whether it is the data of a member or a method, and you made that private, then you can only access that from the class where you have declared it. You cannot access that from a class which is outside that class. Alright, so data members should always be made private. Now you will say that, if I make it private, then how can I use that in a different class? So for that thing to happen, you have to write these methods called getters and setters. So these methods have to be public so that you can access them outside the class in which they are declared. And getters are also sometimes called accessors, and setters are also called mutators. Mutators because they will change the value. Accessors means they will just access that value. Alright, so please keep these things in mind, and this is very important for object-oriented programming, and it will enforce data field encapsulation, which will reduce the chances of misuse by of the data or modification of the data by the outside class. Great. Now let's move to another very interesting aspect of Java programming, which we have been using but we did not know much about it. Access modifiers, which are also called visibility modifiers. So what are these? We know about public and private. I was saying that you should make all data members private, and you should make accessors and mutators, which are getters and setters, as public. Right? So what are these public and private? And what about the fact when you don't declare anything as public or private? So right now we are concerned about three access or visibility modifiers: public, private, and default. Default means when you don't say anything, you just declare, as an example, if you have to declare a radius for circle, you just say, double radius. Alright, what does that mean? That means you're not specifying any visibility. You're not calling that public or private, just leaving it as such. So that will be default. And the default is called package private. Okay, we will understand the difference between public, private, and package private. Now, if you make any class, data, or method as public, then that class can be accessed from any other class, whether that class exists in the same package or in a different package. So package is something which I'll explain to you in my next slide, because I'm using a picture, and that's a very useful picture, because that explains this thing very nicely. Okay, so public, if you're declaring a class, data, or method as public, then it can be accessed or it is visible in any other class. That class need not be present in the same package. It can be anywhere. How about private? If you make your data or method as private, then that data or the method can be accessed only from that class itself. You cannot access this from outside class. Okay, so that is private. Alright, so why is that being done? As I said, for data field encapsulation, just to protect our data. And one of the strong points of object-oriented programming is its data protection. You cannot mess up with the data like you might do with procedural programming. Like in C, you can do that. In C, you don't have anything like data field encapsulation as good as we have in Java. Okay, good. So to the same point, if you have to access data members which you have made private, you need to define the getters and setters. Now the most important slide. So here, let me give you some idea about package before we try to understand the difference between these different access modifiers. In package, we keep the classes which are related to each other. Okay, so related classes are kept in a package. For this course, we have not been emphasizing too much on package, and probably you're writing every program, every Java program in default package, and it all, to large extent, it depends on the IDE that you're using. So the previous Eclipse IDE that I've been using from probably 2017 did not enforce me to create my package. So I was using default package, and all my classes were in that default package. Okay, but For more advanced software development, probably you would like to keep related classes in one package. Alright, so let's look at this example and try to understand the significance of these different access modifiers. So let's pay attention to the figure that we have on the top, one box and the second box. So the first outer box we are calling as package P1. The second one is package P2. Now in package P1 I have two classes, C1 and C2. In package P2 I have just one class, which is C3. So assume that for some reason C1 and C2 were related, and I put those two into package P1, and if I organize my classes in package, then that helps in management. Okay, so that's the reason we should be writing classes in packages, so that the management is good. Great. Now let's try to understand the first class that we have in package P1. It has been declared as public class C1, and here we have three data members. X is an integer which is public. Y is an integer, but we are not saying anything about its accessibility. Z as an integer, we are making that as private. Great. So that was about the data fields. How about these methods? We do have three methods here. We have M1, M2 and M3 as three methods. M1's return type is void, M2, M3, they are all void return type. The only difference in these three methods are in their visibility. M1 is public, M2 we are not specifying anything, M3 we are making as private. Alright, good. So we know what public is, we know what is private, but wherever we do not specify anything, then the default will kick in. And what's the default? Default is package private. So we'll understand what this package private is with the help of this example. So Y is package private, X is public, Z is private. M1 is public, M2 is package private, and M3 is private. Okay, good. So that was about class C1. How about C2? What are we doing in C2? C2 is public class C2, fine, but what do we have inside? Just one method. Return type is void. We're calling it a method. And right here inside this method, what are we doing? Good. We are creating an object O, and its type is class C1. Okay, so this is a reference type, a variable, where it will be storing the reference of an object of type C1 class. And where is this C1 class? Right here. We just defined C1. Okay, we have just defined C1, and now we are on C2. Fine, you created an object of type C1. What can we do with this object? Now, can we access X using O? Right? X is X, Y, and Z. These are all what should we say? Instance variables, and these methods are all instance methods. So we have everything as instance for C1. We don't have any static thing. Okay, so that is a good news. So for instance variable, we will have to use, for instance members, we should use the instance variable period and the member. So we are trying to access X. Can we do that? Yes. Why? Because X is public. So this can be accessed from here, no problem at all. Public means very, very lenient. How about Y? Can I do O dot Y? Yes, you can do that. Why? Because this is, when you're not specifying anything, that means it is private, but it is package private. That means if you remain within this package, then you can access Y. It's package private. So as long as you are inside the same package P1 where the class C1 is declared and where Y has been declared, you can access Y. So we can access O.Y. Why? Y is package private. In this package I can access Y. Can I access Z? No, you cannot access Z. Why? Z is private. Okay, so how about these methods? for the same reason, the reason that I explained here, we can access o.m1, it is public. Can I invoke m2, o.m2? Yes, you can, because this is package private within the package. So since C2 class has been defined in package P1, we can invoke m2. Can we invoke m3? Not at all. Why? m3 is anyway private, you cannot do that. Great. Nice. So if you understood this discussion, then now let's move on to a different package P2. Now in package P2 we have a class, just one class, C3. And what do we have in C3? We have a method, just like the method that we had in C2 class. What are we doing here? We created an object O. What's the type of the class for O? It's C1 class. Now look at it, like how did we use C1? Since C1 is present in package P1, we should put P1.C1. You cannot do C1 O is equal to new C1. No. You can only do that as long as you are in the same package. You are in package P2 and you want to use the class that exists in package P1, then you should have that information. You should say that, I want to use class C1 that is present in package P1. How do you do that? You'll say P1 period C1 O is equal to new. Again, the constructor should also be called in the same manner. You should say P1 period C1. Okay, so that's how you have to call the constructor from a different package, which is P1. Fine, we will succeed in creating O. Now using O, can you access X? Yes, you can, because X is public. No restriction on public. You can access a public member from the same package or from a different package. So we were successful in doing it. What will happen to Y? Can I access Y, which was default, and default means package private? That means that you can only access Y from the same package. So the answer to that is no, you cannot. You cannot access Y because Y is package private. It is confined to the package where it has been declared. Alright, so you cannot do Y. So this should explain you the difference between package private and public, package private and private. Can you access Z? Not at all, because that is private. How about invoking M1 being public? You can invoke. How about M2? You cannot. M2 is package private. M3? Not at all. M3 is private. Okay, so I hope that this discussion helps you. If we are done, let's move further and try to understand the figure that we have at the bottom. Now this figure looks simpler because we had too much text in the figure in the top. Let's see, what do we have here? Class C1. Okay, pay attention here. We are not saying public. We had said public for all the classes in the previous example. Here we are not saying public, we are just saying class C1. What does that mean? That means you have the default access modifier for class C1, which means you can access class C1 only in this package. Alright, this class C1 cannot be accessed from the different package P2 because the class C1 is not public. Okay, so when you leave it default, then that is package private. Now what are we doing in class C2? We're just checking class C2 is public, so that's a good news. Public class C2, and class C2 we are checking that can I access C1? Yes, you can. Why? Because you're in the same package and C1 is package private. So as long as your class is in P1, here or somewhere else in P1, you can access C1. But what will happen here when you move to a different package, like package P2? You have another class C3. Can you access C1? No. Why? C1 is a class which is package private, not accessible outside this package P1. Can we access C2? Yes, because C2 is public. Okay, so that's the reason I like this figure. This is very concise, and with the help of this example it explains everything about access modifier. So I hope you are in a better position in terms of access modifiers. Alright, so now we have this UML again, but now this UML is for our class circle, which we used to understand object-oriented programming. We created circle class, we used that to create objects, and we also added static data members there, static methods. Good. So let's put all the information that we have learned so far about this class and UML. So circle, the name of your class, radius is private, so you're making that as minus. Its type was double. Number of objects has to be private again, so we will put a minus sign there. It is of type integer. So please learn these rules. You might be asked to create a UML in exam or maybe in your interviews. Alright, you might be given a UML and you need to implement that. So this will only happen when you understand these UMLs really well. Good. So why did we underline number of objects? Because it is static. So what is circle? The first constructor, no arc constructor. The second circle is a plus. These are all public, so that's the reason you have plus before them. Circle is an arc constructor. The argument that you're passing should be of double type. Get radius is a public method which is returning the double, so you should have a colon and then the return type after the name of the method. What about set radius? Set radius is public, which will change the radius value to some value that user wants to reset the radius to, and it will simply change the value. It will not return anything, so its return type should be void. How about get number of objects? It will return an integer value, and since it is a static member, static method, it should be underlined. How about get area? It's a public method. Its return type is double. That's it. Okay, then you have the explanations right here. This is an interesting thing, which is about the question that well, good, we are learning about objects, then can we use objects to create an array? Why not? Yes, you can do that. So we need to be a little careful how we should create an array of circle. Why? Because we have been using let me try using pen if that helps. So till now we have been doing something like this. We did int, let me keep it very simple, int, and you created something like this, and you said arr is equal to, you set a new int and 10. So this is something we have been already doing. And what happened when we did this? Well, we created an array of type int, and with this help of new and int and 10, we were able to create an array that was capable of holding 10 integer values. What we need now, we need to create a circle array. So what should happen? In place of int, we should write a circle. So that's what we are doing right here. So we are saying circle. Alright, so that's the difference we have made now. In place of int, we are putting circle. Okay, rest of the things are almost same, and same in the similar manner. This int should be replaced by circle, and you may say circle array, I am keeping that short, is equal to new, and in place of int I'll write circle again, specify the size. Done. Alright, that's precisely what we are doing. So yes, it is possible we can use objects to create an array as well. So what will happen when you create an array of objects? Well, then this circle array and the variable right here will be holding a reference. So that's what we mean. So the circle array variable that you have is holding a reference to an array. It is holding a reference to an array, and each element in this array are further holding the reference to the circle objects that you will create. Okay, so that's the only thing which has changed. In ARR, you'll be holding a reference to an array in which you will have these 10 integers. ARR is holding a reference to an array where every element is an integer value. Whereas in case of circle array, you're holding a reference to an array where each element is not holding the exact value, but instead holding the reference of the circle objects. Okay, so that might make it slightly complicated, but otherwise, yes, you are allowed. You can create an array of objects. We did that right here. Now this is an interesting thing which I believe I will take in the next video lecture. I will, as usual, encourage you to try out these programs and see for yourself. And if you have any questions, please reach out to us. Thank you so much. Have a good one.